Welcome everyone to our short mini video series on TruEra Diagnostics, where we'll be showcasing the ML test harness. My name is Daniel, and I'm the current product marketing manager here at TruEra, and joined with me today is Josh Rainey, who is our data scientist developer relations, who will be walking you over how to set up these tests. Just a quick overview. Our test harness feature simplifies the workflow of data scientists when it comes to creating tests. Our test harness feature provides a more systematic approach when it comes to creating tests, and it can be done via notebook/SDK, via TruEra UI, as well as automated pipeline, and also provides the ability to recreate tests that have performed well for prior models, and you can apply it easily to newer version of models, which creates that consistency. Our test harness feature comes in 3 different tests: performance, stability, and fairness. Each of them comes with their own metrics and thresholds that users can set up. Now I'll hand it over to Josh to show you an example on how to set up performance testing for our test harness feature.
Thanks, Daniel, for the introduction, and welcome to TruEra. Today, we'll focus on how to use the TruEra test harness in order to build trust into your machine learning models. In particular, we'll focus on testing for performance. Today's project will focus on an Airbnb price recommendation model where you are providing a price recommendation to new hosts so that they can give the right price for their listing. This model was trained on San Francisco, and then we'll use Seattle as the test data. Here we've already created 3 versions of the model: XGBoost, XGBoost 2, and XGBoost v3. And we'll use the test harness to establish which of these models is the best. Let's go over to the test harness and define our first test. So we want to use a performance test. And let's name it Performance in Seattle and give it a slightly more descriptive description. How about mean absolute error in Seattle? We have a variety of metrics to choose from. As I mentioned in the description, we want to use mean absolute error in this case because we want to have an easily human understandable error that we can market as the core service to our business. We will set our fail condition to a threshold of 100, and then a warn condition to a threshold of 80. Note that we can also set a relative threshold for both data splits and models, but in this case, we'll use absolute thresholds. Continue on to step 2. Here we can choose to apply this test to all data collections or just some manually selected ones. Let's go with all data collections. And then we can also apply it to all data splits, or we can only choose to evaluate it on some data splits using a regular expression. Let's use the regex to look for only Seattle data splits. Then we can choose update to make sure we match the correct Seattle splits that we were looking for, and continue on to step 4. So here we can just finalize that we define the test we are looking to create and click Save Test. Now we can see the test we just created in the test harness page, and we can head over to the model leaderboard to see how our model did. So let's change the evaluation metric split to Seattle and update the leaderboard. So here you can see XGBoost v1 failed the first test. So that's shown with the red here. And then for version 2, you can see we made a change that improved performance from 110 to 81. And now we moved the test result from fail in v1 to warn in v2. Last, we made a third change to then move the performance to a passing grade, shown in the test result as green. If we want to dive further, we can then go into the model summary page to look a little bit closer about how it passed this last test. So here we can see performance in Seattle evaluated on data splits Seattle with the test metric mean absolute error, and that we passed the test with a mean absolute error of 76. If we hover over, we can see our warning condition was 80 and our fail condition was 100. So this meets our expectation with the mean absolute error being lower than the warning condition. Last, we can click on the performance page to dive even further into the performance of this model. Thanks for coming along to learn about the TruEra test harness, and I'll see you next time.
As you can see, our test harness feature simplifies the workflow for data scientists when it comes to model development, and it allows them to debug problems ahead of time. For more information, please download our white paper from this link. Thank you.